We present dynamic element textures, a general-purpose methodology to analyze and synthesize a variety of dynamic effects, including herds, threads, and sheets. Our method can control the output in both the coarse motion and fine scales. Here is our baseline demo of little spheres, each representing a point sample. The user specified the coarse output domain shape, which is a circle in this case, and a detailed input exemplar, which is used to guide the local distributions of the output spheres. Notice how each frame produces arrangements similar to the exemplar, while exhibiting a plausible dynamic behavior. Our baseline solver can be augmented with additional controls, such as physically based simulation for collision detection, as well as smooth synthesis to reduce jittering artifacts caused by a traditional solver. In this example, the flock of fish is entirely animated by our synthesis method from the small animated exemplar shown at the bottom with a homogeneous distribution. The coarse output domain is simply a box. This is one example about temporally heterogeneous behavior with some fish rapidly transitioning between different groups. And this is one example about spatially heterogeneous distribution of fish with different sizes. Our method works for different kinds of input sources, including captured video shown here. We can also work with captured image input. In this example, we manually prepare two static frames based on a photo of a willow tree, and then use them to guide the synthesis of dynamic tree branches. The output still looks natural due to our graph synthesis method. Here is another example using a few more frames. As shown, our graph synthesis can produce results very similar to one produced from a dynamic input. Here we apply our method for dynamic spaghetti. Given a simple coarse output motion and an exemplar with realistic detailed motion, we can produce a realistic output. Our method can even take artistic exemplar, such as jaggy motions. Our method also works with 2D sheets. Here, we use different input exemplars to achieve different effects of paper scraps. The first input exemplar is obtained via physically based simulation for realistic deformation, while the second one is manually animated for artistic flapping motion. In addition to synthesis, our method can also be applied to analyzing given inputs. Here, we extract the large-scale coarse motion from an input hair animation. Users can choose the desired degree of output smoothness by using different analysis kernel sizes. After that, we can add new details to the coarse hairs. In other words, we keep the coarse hair structure and motion, but replace the details with different input exemplars. The small input exemplar is shown in the middle, while the final output is shown on the right. Notice the geometric details and additional motions introduced by our method with different exemplars. Finally, we show an example of large-scale synthesis for particle flow. Thank you.